Hello, and welcome to
Small Talk about the Big Issue. I'm Kiara.
And I'm Lorraine, and I'm also very excited about this episode. I think within this ocean unit, we've delivered some pretty harsh science about sea level rise, the implications of ocean acidification, of the potential of huge climate deregulation because of the AMOC collapse. And throughout, we've stressed the importance of a very simple solution to all these problems. We need to stop emitting greenhouse gases. But in my mind, this episode is the one when we delve into the promise that the ocean holds for doing just that.
Wow.
For capturing carbon and reducing the amount that we're putting out into the atmosphere.
And we'll do that by answering, what is blue carbon?
Yes. So we're going to be talking about blue carbon, which is very exciting also because it involves photosynthesis, my area of study.
Here we go again.
So I'll just set the scene about what blue carbon is and the promise it holds to regulate the climate and mitigate the emissions that we're releasing. And then Kiara?
I will do something a bit different today. I have two articles.
Whoa!
One good news, one bad news. You'll get to choose which one you want to start with.
Okay.
One is going to be very much solution-oriented for sure. That's something I can promise.
Okay. So I just want to very briefly set the scene and give you lots of numbers about the ocean. The first, and I can't believe we haven't mentioned this in this unit before, but life began in the ocean.
Yeah.
As in the origin of life is in the ocean. 70% of our planet is covered in water. Most of that is salt water from the ocean. The oceans have absorbed 90% of the heat from our emissions of carbon.
90%.
I know. The oceans are also the greatest carbon sink on Earth. They absorb about 30% of all of our carbon dioxide emissions, and they generate 50% of the oxygen we breathe. So I heard there's this great TED Talk that I saw by Susan Ruffo. Highly recommend everybody watches it. It's like 8 minutes, and it's about how many solutions the ocean can provide to facing climate change. And one of the things she says is, and puts into perspective, I think beautifully, she's like, every other breath you take has oxygen from the ocean.
That's beautiful.
Which is beautifully said and also perfectly captures just how important the ocean is for us. And all these great things happen in part because of marine life, especially photosynthetic marine life. And essentially, these organisms are really good at storing carbon. And we've talked about carbon stored in the shells of marine calcifers in the previous episode, but the real stars of the biological carbon pump of the ocean are microalgae and phytoplankton, which are similar things. And there are hundreds of thousands of species in the oceans, and they help capture tons of CO2. In fact, I mentioned that the ocean absorbs about a third of all carbon dioxide emissions. Most of that is because of these tiny, tiny organisms just floating around and capturing carbon through photosynthesis. And together, they produce more oxygen than all the trees on Earth combined.
Wow.
So I think that really, again, stresses how important the ocean is. And they're key while they're alive because they also provide food for larger fish. So they're these really key basal parts of the ecosystems. But they're also helpful when they die because they can then sink into the deep ocean, and the carbon that composes their bodies will then sediment and stay stored for a really long period of time.
We might be getting ahead of ourselves for next episode, but it's definitely promising.
And so this is kind of the main mechanism by which oceans store carbon. And I actually wanted to do a little side note. The previous episode was on AMOC, this current that goes through the entire Atlantic, and it's key for redistributing heat between the South and the North Hemisphere. But it's also a vital nutrient pump. And so we had discussed the possibility that the AMOC was
slowing down,
weakening. And so one of the ways that climate change is impacting the ocean's ability to capture carbon might be that nutrients are less available for all this phytoplankton. Marine coastal ecosystems are also fascinating because they're so rich and diverse, but also have this incredible ability to also store lots and lots of carbon, even though they cover a minority of our coasts.
Mm-hmm.
Ecosystems like seagrasses and mangroves and kelp forests that can also absorb huge amounts of carbon. In fact, mangroves, for example, can store about 1,000 tons of carbon per hectare, both in the kind of biomass of the trees that make up the mangroves and in the soils that make up the mangroves.
Wow.
And one of the ways that everything that we've discussed about the ocean so far in all our previous episodes is linked is that these coastal marine ecosystems help protect against floods and storms caused by sea level rise. They help decrease the acidification of the oceans.
We owe them for so much.
Yes. And they provide, a lot of economic benefit through healthy fisheries and tourism, etc. And so one of the points that I wanted to make was that healthy marine ecosystems are key to help us mitigate climate change and store carbon.
We depend on them.
But they can also be detrimentally impacted by climate change. And climate change can really destabilize these ecosystems and reduce the ability of the ocean to absorb CO2.
In a way, you're saying that we might be losing very good allies in a fight against climate change.
Exactly. But, and this is the resource that I'd recommend for people to watch when they step away from this episode, Kiara and I watched this beautiful documentary called Oceans.
With David Attenborough.
And so he talks about a lot of the things that we have discussed with these beautiful images of marine life. So if you want to go see what a kelp forest looks like, some of these giant kelp are the tallest living organisms in the ocean. But one of the things that he stressed after presenting all of this was how fast marine ecosystems can recover. So kelp, for example, can grow 2 meters in a day.
That's really hard to imagine.
I know, it's like the height of a very tall human being every day.
Wow.
But, and this is the kind of final point of the introduction, is that means that we need to protect oceans. And this is very important to mitigate all of these issues that we've discussed previously, as well as to conserve this essential carbon capturing function that the ocean has. Right now, we're protecting about 3% of our oceans.
Yeah.
And scientists have determined that to have stable ocean ecosystems, we'd need about 1/3 of oceans being protected. And this is when I think I have some really good news to share.
Okay.
Which is that as of, I think 2 weeks ago, when we record this, so it might be a bit longer when this is posted, but the High Seas Treaty received its 60th ratification from the state of Morocco. And it means that now all 60 of the countries that have signed it are legally bound to protect 30% of oceans by 2030.
Which is in less than 5 years, which is very exciting to have such quick, promising action.
It is, and I really can't stress enough how big of a deal this is. This international agreement has been like 2 decades in the making, and it holds huge promise for the future of the ocean.
And we've seen through the movie, for example, that as soon as a patch of ocean is protected from overfishing, it starts being productive again. And this doesn't only impact the protected area, but areas around it will see an increase in biodiversity. So protecting even 30% of the ocean will have an effect that is much bigger than just in those areas.
Exactly, and it will allow us to keep benefiting from what the ocean gives us, like food, for example. And I was going to mention this fishery example where protecting the ocean actually means that potentially we will have more fish because there will be places where fish can breed and grow in peace, and they tend to spill over and then be available
in non-protected areas where we would be allowed to fish.
Yes.
While it's still being a sustainable practice because they would always have safe spaces to return to and breed.
Exactly. So this is hopefully a good whistle-stop tour of all the amazing things that photosynthetic organisms in the ocean do to capture carbon and to regulate the climate through that, and a lesson in just how important it is to protect the ocean.
Agreed. So I hope that by now you've made the connection between blue carbon and the photosynthesis that is happening in the ocean.
Oh, yes.
We're talking about blue carbon because it's the carbon that is being sequestered by plants in the ocean.
Yes, yes, yes.
Which is a good transition to one of my articles, which happens to be the good news.
Okay.
Would it be all right, Lorraine, if we started with that
yes,
one?
absolutely.
I usually prefer starting with the bad news and finishing up with the good news, but the flow is just too right to disrupt.
uh-huh.
So the very first article I wanted to present is called Carbon Burial in Sediments Below Seaweed Farm Matches That of Blue Carbon Habitats.
Okay.
It was published on the 17th of January 2025 by an international team led by Carlos Duarte. And they looked into seaweed farming as a potential blue carbon strategy because it's been talked about for a while now that farming seaweed could be a way to increase CO2 absorption from the ocean.
Okay.
Right now, seaweed farming is mostly used for food, cosmetics, biofuel, but wild seaweed forests in the ocean are one of the biggest carbon capturers out there. They sequester more than mangroves, seagrass, and salt marshes combined.
Oh, wow.
So that could be why they've gained such a big interest in recent years when it comes to climate change mitigation. The thing with seaweed farms is that they're usually placed in bays with soft sediments, so in better conditions than most natural seaweed patches. Yet there's never been estimates of how much carbon can be stored by them so far. So this is what this study did. And they quantified this carbon burial in around 20 seaweed farms around the world that were of different ages and of different sizes. What they noticed is that the thickness of the sediment layer and of how much carbon was accumulated increased with how old the farm was, which does make sense. The older the farm is, the more the seaweeds have had time to store carbon. And they found that the rate of carbon sequestration of those seaweed farms was very similar to the low range of that of blue carbon habitats, so of natural seaweed forests.
Okay, so even though seaweed forests tend to be in less good soil conditions, they sequester carbon at a faster rate, maybe because they're part of more complex ecosystems.
Yeah, it could be that, but the bottom line is that it's actually a very close number. There's not that much of a difference. And this rate got higher the older the farm was. So it could be that natural seaweed forests are just very old and undisturbed. Whereas there's no seaweed farm that's older than 200, 300 years old.
Okay. And just to be clear, by a farm, do you mean something that's regularly cut and processed? Is it like...
Yes.
Okay.
It's a commercialized production.
Does that sequester carbon effectively then? Because potentially when we cut the seaweed and we process it to make cosmetics or food, as you said, we're releasing it back into the atmosphere.
Yes, they look at the amount of organic carbon that is being accumulated below the farms, so in the sediment.
Okay, just in the sediment. So even if you regularly cut these seaweed plants, the carbon that's accumulated in the soil is like that of a natural seaweed ecosystem where they aren't cut regularly.
Yeah.
That's really impressive.
It really is. So I thought that was a good news worth mentioning. The second article is really fresh news. It was published on the 2nd of September 2025.
Okay.
So barely a few weeks ago. And it's called Unexpected Decline in the Ocean Carbon Sink Under Record High Sea Surface Temperature in 2023. So this is fresh climate news. It got out on the 2nd of September 2025, so barely a few weeks ago. And what it showed was that the ocean absorbed 10% less CO2 in 2023 than what was expected under current knowledge of how much the ocean can absorb CO2. And this is surprising because it was a year with a strong El Niño event, and usually El Niño events are correlated with a boosted CO2 uptake by the ocean. This is because El Niño weakens the trade winds, which usually drive surface water westward and allow the nutrient-rich, CO2-rich deep water to rise along the equator.
Okay.
And when there's weaker wind, well, there's less upwelling of CO2. So what happened was, in spite of that very strong El Niño event, where we would have expected to see less release of CO2, well, there was actually a lot more release from the ocean than we could have predicted. The ocean released enough CO2 that year that but it had a real impact on how much was actually absorbed in the end. 10% less than what was expected.
Do we know why?
So this is because 2023 was a very dramatic year for sea surface temperatures in the ocean. They reached a record high level, and so the water temperature was so high that the absorption of CO2 was made really, really difficult.
Because the plants for the phytoplankton's photosynthetic ability was compromised?
No, this is chemistry. The warmer the ocean is, the harder it is for the ocean to take up CO2.
Ah, okay.
It loses its ability to dissolve CO2 in its water. And that led to the ocean absorbing 10% less CO2 than what was expected that year. So this is a phenomenon that's only going to increase as we see more extreme events of sea surface temperatures. 2023 was one example, but it's definitely not going to be the last. And every single time one of these marine heat waves happen, we're going to see a decrease of how much CO2 our ocean is able to absorb.
This is really interesting because one of the resources I came across in preparing for the introduction of this episode said that if there's more carbon in the ocean, potentially plants and phytoplankton can do photosynthesis more efficiently.
Yeah.
But what you're saying kind of nullifies that effect, because if there's more CO2, it's warmer, and so the ocean is less able to dissolve CO2 in the water.
Yeah.
And so actually plants don't have more or easier access to CO2.
It's a tug of war.
That's really interesting.
So I'm sorry for finishing on a bad note, but I still hope you can remember all the promises the ocean holds and how much potential there is in just protecting our oceans and giving it a chance to right some of our wrongs.
Beautifully said.
But that only works if we do the work and if we keep on working on diminishing our greenhouse gas emissions in parallel.
It always comes down to that, I think, is the slightly redundant lesson that we're getting at. All right. Thank you, Kiara, for telling us about all this very recent climate news. Thank you, listeners, for listening. If you have any questions, comments, or feedback, we're always very happy to read it, either in the comment section of wherever you're listening to this, or you can send us an email at smalltalk.bigissue@gmail.com.
Stay tuned and see you next time.
Goodbye.
We fact-checked this episode and wanted to clarify a few things. We used the terms microalgae and phytoplankton, but realized upon editing that these deserve a definition. Phytoplankton are aquatic microscopic organisms which carry out photosynthesis, and macroalgae are one type of phytoplankton. Early on, Lorraine says that the oceans can help us capture carbon and reduce the amount that we're putting out into the atmosphere. A clarification of that thought. Oceans can capture carbon, which would help compensate for our carbon emissions, but we are the only ones who can reduce our carbon emissions. Lorraine also says that plants may not necessarily have access to more carbon under global warming because the ocean's ability to chemically dissolve carbon decreases as temperatures get warmer. A more accurate statement would be that the amount of carbon dissolved in ocean water and available to oceanic photosynthetic organisms will not increase proportionally to rising temperatures. Phew, that was a mouthful. That's it for this week. See you next time.